Monday. How's everyone doing today? Oh, I'm sorry. That's not fun. Good. Three of us are here paying attention, answering. That is not a good start, friends. Come on, let's go. There we go. A few of us waking up now. Ugh, another one's sick. I'm sorry. I know that's not very fun. Did you guys have a good weekend? Did you do partying, Super Bowl fun? Did you have anything special going on? Okay, a mix of people who watched. Some of us just go to the parties and don't watch. I'm sure that's always a thing. Oh, fun a birthday this weekend. Nice. Work and a few play things. Okay. So, yes, tons of fun for all of that week. So, today I told you we're going to start our work in triangles. So, my biggest caution for you for triangles is it gets confusing for people when you aren't diligent in paying attention to the details. Because for this, you'll start with something that the first week, super easy, makes sense, you really don't struggle with it. And then second week, a little bit. And then we start putting them all together, and you're like, oh man, okay, there is a whole lot that I kind of rushed through a little bit as far as the actual understanding of it. And so it gets to be more difficult when it comes to putting it all together. So pay attention to the details. Make sure that when we're talking about angles, you're not just like, oh, okay, this week I see this, I do this. Like, really try to make an effort to understand what's going on. Like, we'll talk about an inscribed angle. What does that mean? What does that look like? So that next week, if we start talking about central angles or interior, exterior angles, you have an idea of what the vocabulary means, not just week one, see this, do this. Like, the understanding is what will make a difference in being able to do well when we put all the things together. Does that make sense? Okay. Okay. So let's go ahead. We'll say our word of prayer and then we'll get started on what we're learning today. Okay. So if as we're doing this part where we're doing our um, prayer time, if someone had asked me about this, I wanted to answer it before I started my actual prayer. If you come during this time, I probably won't let you in until after the prayer. So sometimes people will come in at this moment, like I was getting ready to start and someone came in. So just it reminded me that someone had asked me about this, about having to wait in the waiting room a little long when class had already started. That's why if I'm already praying, I'm just going to wait until we're finished to let you in. So I wanted to say that to answer that person, but also to explain to everybody what if that happens. So here we go. Dear God, we just come before you today, God, and we just humble our hearts, surrender our hearts to you. God, I just pray that you would give us eyes to see the future that you have for us and give us motivation, effort to work for that. Because, God, we know that you shape us and form us in that work. We know that we do that unto you and that you are glorified with that. God, I pray for those who are sick just to have your total, complete healing and restoration. I pray for just health for their entire family and that everyone would be able to be well. And God, those that are traveling in this week or next, I just ask that you would watch over them, protect them, and keep them safe. We love you and we thank you. And we ask all of these things in your name. Amen. All right, let's start with our brain stretches then. Get everybody moving here. So we've got two different types of brain stretches today. First one will be our our three phrase relationships. This is our tribond. So you're looking for how these three words or phrases are related: clock, monkey, and a card game. A clock, a monkey, and a card game. So take just a minute. This spin is not anything to do. This is last week's spin, so don't worry about that. But I will spin for who's going to give us their answer first here in just a moment. But right now, I want you to think, what do those three have in common? All right, so our first answer will be given by, will be given by AJ. AJ, how are these three words related? Got a guess? Okay, everybody else guesses? There you go. Lots of people putting answers in now. There you go. They all have hands. That is correct. Next, a mug, a door, and a bicycle. Take a minute to think about these first, and then we'll come back and discuss them. Okay, so our first guesser on this one is going to be James. James, got a guess for us on this one? No one should be working on this except James yet. Let him go first. All right, everybody put answers in. Very good. All right, one more set of these: a baseball glove, a pool table, and jeans. A baseball glove, a pool table, and jeans. Okay, let's see here. All right, Tears, got a guess for us? Good. Everybody put answers in. Very good. They all have pockets. That is correct. Okay, one more. I brought back an oldie but a goodie, one of our pictures. So try this one, and then I'll get someone to give us the answer for this one here in just a minute. Okay, Bridger, have a guess. Okay. Everybody put your guesses in. Good. Several people with answers. Everybody put your answers in. Okay. Got several of you who didn't, or a few of you, I'm sorry, who didn't put an answer in. Just looking who I see that doesn't have an answer in. Watchman, did you put an answer in and I missed it maybe? James, did you get, I see your answer come through now. Yes. I know that's what was stuck in your mind, I guess. Watchman, you didn't want to put a guess in? You still haven't responded. Okay. Correct answer for this one. This is Space Invaders. So, Space Invaders. Oh. Ha, 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 ha. Yay. I mean, it's very literal on that one, actually. Yeah. I mean, look at it. You see it. You got to be able to see it now. You should have seen that in the word Vaders, there was a space in it. So there you go. All right, let's talk about homework questions. Anybody with homework questions from last week? Okay, let me put those up here then. Okay, let's see. Similar figures worksheet. Let me start there. Okay, good. Just a second here. I'll get it up on the screen. Makes it easier to go over that way. Okay, let me see here. Sometimes I have to look and make sure I have the right worksheet here. I don't think that's it. Let me double check that I'm on the right worksheet here. Sometimes the way they're saved for me looks a little different than the way they are for you, so I want to make sure I have the right ones. Okay, so on this one, okay, for number 4, the part that gets a little bit confusing for us and that we often kind of miss out on is that when we're looking at our shapes, here is one shape. That one gives us no trouble. But its similar shape is not this one. That shape is not similar to it. So I can't use the 4 just like it is. I have to use this shape as its similar figure. So if I'm setting up a proportion to try to find my missing side, I would say 16, which is the small triangle, over that same side in the big triangle is the 16 and the 4 combined to make 20 equals W in the small triangle over in the big triangle 12. Okay, so there's my setup for that one. It only asks me to find W. Then for number 5, I have one pair of sides that correspond that I know. So I have to use those. Yes, a lot of us do that. We don't look at it as a similar shape. We don't look at it as two triangles combined together. You're right. So for this one, my sides that are corresponding are 4 and 10. So to find J, I would say 4 over 10 is 3.8 over J. And then to find K, I would say 4 over 10 is 6 over K. I'm just setting them up. I know that you guys know how to solve them. It's the setup that you struggle with. So if you look at the setup here, I feel like that'll help you feel more confident with what you're supposed to do. So looking at that one, does it make sense? Is there anywhere that you have a question on either of those? So 6 is exactly like 4. You're going to say small shape over big shape equals small shape over big shape. Okay. Does it make better sense now, Gavin? Like, can you see what the shapes look like that you're trying to match them to? Okay, good. Everybody else feeling like it makes sense how to set them up? Okay. As long as it makes sense now, we'll call that a win. Okay. Did I see other questions? Sorry, I'm scrolling back to see if I see anything or other people were asking. Okay. I don't see any other questions. So if you asked any and I missed them, feel free to ask again before we move on. Because where we're going from here is not going to be dealing with this, right? It's going to be something totally different for what we do next. Okay, Abel, well, you can work them out again and double check if you need to do that. Feel free, please. That's why I'm trying to put them up here, but be super cautious about not because a lot of you guys are saying you feel like it doesn't. You need to see every step. You need to see the setup. So work it out and double check it. And then if you have a question, just either you can send me a message or send me an email. Either one. That way you can kind of check it out. There it goes. Okay, so like I said, today we're switching gears and moving into a conversation about circles. Yep, when we're trying this again on circles. We know that we have some foundational understanding of circles, but I'm likely going to repeat stuff you already know about circles because just because you know it does not necessarily mean that everyone knows it. And I like to make sure that we all start on the same even ground so that if we have things that maybe we learned and other people didn't learn, or vice versa, we don't miss an opportunity to ensure everybody understands things properly. So that's why I typically will start these with here's the basic stuff. And if you already know that, great, you get a win. But if you don't start off behind. You start off on the right foot. So as we go through this, you're not struggling from the beginning on something that we could have taken care of easily. So just beware, like when I start with circle basics, I literally mean circle basics. So the first thing that I ask you to do or talk about with you is naming your circles. That sounds silly, but some people have not really ever been exposed to what you do when you name, how things go. Okay. So it says, name the circle, name a radius, name a chord, name a diameter. So before I ask you to do that, I want to tell you the basics of how to do that. If you already know, great, you can work on it, no problem. But in case you don't, when you are naming a circle, you name it by the center. So for example, if I'm looking at the second one, you'll notice that I named it circle A because its center is in at point A. Simple enough. Okay. A radius of a circle starts at the center of the circle and goes to the outside edge in any direction. Okay. A chord of the circle goes from one side of the circle to another side of the circle. And then a diameter is a special chord that goes from one side to the other side through the center. Okay. So just wanted to make that a little easier to understand in case you didn't know. So take just a second, name all of those. You don't have to name them here. So a chord is a special, I'm sorry, a chord is a segment that goes from one side of the circle to the other side of the circle. If it goes through the center of the circle, then that's a special chord that we call a diameter. Okay. Okay, so for my picture at the top, if I were going to name that circle, I would call it circle K. If I were going to name a radius, there are several examples here. I could call it KO, KN, KP, KR, KQ. Any of those would be considered a radius of this circle. You do plural, they would all be considered radii. Okay. A chord, for this one, I have two possibles that I could list for a chord. So I could say that that segment NO is a chord, and I could say that that segment RP is also a chord. But then when we talk about a diameter, only one of those is a diameter, and that's RP. Questions on any of the vocab there? Can a chord go? It can. It can. So diameter is just a special type of chord. So yes, that's still considered a chord. Yes. Okay, I don't see any other questions. I'm just flipping through. I think everybody's good with that one. Why not RKP? So when we name a segment, we only use two letters. So RP is all that you need. RKP is unnecessary to have three letters. You only need two letters. Now, if you called it PR, for example, that's still the same segment. Somebody asked about that as well. Yep, good. Okay, the second part says circle A has diameters DF and PG. So let me remind you, hopefully it's just a reminder, but let me remind you, if a radius goes from the center to an outside edge and a diameter goes from one edge to the other edge through the center, that means if I put a radius, let's see on our original picture, the radius KR and the radius KP, if I put those together, that made the diameter, which means that a diameter is made up of two radii. So the length of the diameter is twice as long as the radius, the length of the radius. So look at the two questions left on here. See if you can answer those real quick. It should be real quick. So for this one, it says if DF is 10. So what kind of segment is DF? Okay. So a chord is good, but more specifically, it's a diameter because it goes from one side to the other side through the center. So it is a diameter. So if from D to F is 10 units, how long would it be from D to A? Okay, good. That would be half as much. So that would be 5. Agree. So now it says if AG is 10, find LA. So what is segment AG? What type of segment is that? Okay, good. It is. It's a radius. It goes from the center to the outside edge. So it is a radius. How about LA? What is that? Yep. It is also a radius. Good. So the measure of one radius is going to be the same as any radius that you could draw. So if AG is 12, that means LA is 12, AF is 12, AP is 12, AD is 12. Any radius you could draw would also be 12. Make sense? Good. Okay, let's look at another part. So, our next part is talking about a central angle. So, a central angle is going to be formed with the center of the circle as its vertex. Okay. So, if its center is at the vertex, that means from the center to one side, from the center to the other side, those are the two sides of it, which means the sides of a central angle are formed by radii. So if I look at the picture at the top, when I add up angle 1 plus angle 2 plus angle 3, how many degrees would that be? Very good. Because when I put those 3 parts together, they make that entire circle. They cover the entire circle. So the sum of all the central angles in a circle would be 360 degrees. So use that idea and solve the the question that's there. It's on the screen now. Solve that one. So here's what a lot of you start doing. Start going through all of this, and then you get to a point where you're like, I just have to kind of guess which one I think is the same size as QTR. But the problem is you don't know one that is the same size and you can't just guess. So this way, if I start adding them up and trying to set them equal to 360, this way is not going to work. However, if I look at my picture here, what do you notice about segment RTV? Okay, good. It's a diameter. So what does a diameter do to the angles of, or to the measures in a circle? What would a diameter have to do with that? Okay, good. So if the entire circle is 360 degrees, then the diameter cuts it in half so that each semicircle or half circle is 180 degrees. So now you can use what you see there. And instead of setting them equal to 360, you can use just the part on the right side and set it equal to 180, like this. Questions on just the setup of that one? Makes sense so far, it looks like. Okay. Should be -2. Typing didn't work that time. So when I solved this, I got x was 7. Good. Okay. Good. Several of you are saying, yes, you got this. Okay. Okay. Then it says a central angle separates the circle into two parts, each of which is called an arc. Sometimes arcs can be measured in length, like how long they are. Sometimes they can be measured in degrees if we're talking about how big the angle is. Both of those are ways that we will use when we're measuring them. So it's just going to be important to realize, am I talking about degrees or am I measuring the length of the arc? And we'll look at both. Okay. So take a minute. You're given just a little bit of information. See if you can use that little bit of information for all of these. You're measuring them in degrees. So see if you can use just little pieces of information that I gave you and answer as many of these as possible. Don't worry if you don't feel comfortable with all of them yet. We're going to go over them together here in just a minute. Okay, so take a minute. See if you can find all 6 of these or some of them. If you can't get all 6, that's okay. We're going to go through them together. Don't worry. Okay, I'll give you just a few more seconds and then we'll go through them. Okay, so for this one, if I know the measure of DFA is 50 degrees and I know that CF is perpendicular to FB, then I know that creates a right angle, which means that this is 90 degrees. Oops, that's hard to see on there. Change colors. See if that makes it easier to see. Okay. So the first thing it asks me for is BE. You could look and see that this angle, DFA, is the same measure or is a vertical angle to BFE or EFB, meaning this one would also be 50 degrees. And if the angle is 50 degrees for a central angle, this is true only for central angles. We're going to come across others where this is not true, and you're going to try to tell me it's true. And I'm telling you from the beginning, if this is true of central angles only, but whatever the measure of my angle is, my arc is the same measure. So that means if EFB is 50 degrees, then arc BE is also 50 degrees. Then it asks me about arc CBE. Now, some of you may be wondering, wait, why is it giving me 3 letters instead of 2 letters? We'll come back to that here in just a minute. I'm just going to tell you now. We'll talk about why in just a minute, but just know what it's talking about for CBE. So for arc CBE, I'm putting together the 90-degree angle from CFB and the 50-degree that we just found, the 50-degree arc that we just found. So this one should be 140 degrees. Okay, now you'll notice that C is asking me about arc ACE. Okay, so there's lots of parts of that. We know we have a 50-degree angle, another 50-degree angle, a 90-degree angle, but there's an angle we don't know yet. How could I figure that out? How could I figure that angle, that missing angle out? Okay, so there's 2 ways you could figure it out. You could divide your circle right here in half and subtract from 180. Or you could say, all right, if this is 50 degrees, I know that half of it is 90 over here, which means this half has to also be 90. Either way, you should figure out very quickly that CD is 40 degrees, which means A to C to E would be 50 plus 50 plus 40 plus 90, which would be 230 degrees. And then now it's asking for DCB. That one's easier. You have all the parts that you need for that one now. So DCB is how much? How much is DCB? Mhm. Good. I agree. 130 degrees. Then finally, CAE. Now, we haven't done anything with AE yet, but we already know the other part of the circle, CBE, is 140 degrees. So I wouldn't even necessarily have to add up anything or find all of my parts. If I know that from C to B to E is 140 degrees, and now I'm going C to A to E, that would have to be 220 degrees. Questions on any of these? Okay, so we're going to take a quick break. When we come back, we're going to speed run through several of our different topics here because there's a lot of parts for what we need to get through, and hopefully we can get most of it at least introduced, but hopefully we can even get through the practice problems as well. But for now, enjoy your break. See you guys back here in just a few minutes. All right, so let's look at some of our other topics that we're going to look through circles. Okay, first is finding a circumference. So, if you remember, circumference is like the perimeter of the circle. You're finding the distance around the outside of the circle. There are two formulas, and you can use either one. One says multiply the diameter of the circle times pi. The other says multiply the radius times 2 times pi. So what's the difference? How will I know when to use one formula versus when to use the other? Okay. So if I'm given if I'm given the diameter, I'll use that formula to find the circumference. If I'm looking for the circumference, but I'm given the radius, I'll use that second formula to find the circumference. So it's all dependent on what I'm given. Yep, what I'm given will determine what I do with it. So look at your two problems here. Pay attention to what you're given and just set up the formula to find the circumference. We're not going to worry about doing the actual calculations because I want to get through it as quickly as we can. So just set it up. And then if you get those finished, also set up the next one where it gives you the circumference and asks you to find the radius. Okay. I'll go ahead and write them here on the board so you can check your answer. Okay. So for the first one, it gave me the radius. So I used the second formula and plugged in the 7. The part B gave me the diameter. So I used the first formula and plugged that in. If you look at the bottom, it gives you the circumference and it asks you to find the radius. So you need to use the formula that includes radius. And instead of plugging the number in for the radius, this time you're going to plug that number in for your circumference. So how would I solve to find the radius on this particular problem? How would I solve this one? So basically, you're trying to solve for r, so you're just going to divide each side by 2 pi. So in my calculator, I would say 20 divided by 2 and divided by pi. Questions on any of those? Everybody feeling okay with it, I believe. Okay, very good. So let's look at the next topic. Okay. So the next one is now instead of asking for degrees for an arc every time, sometimes it's going to ask you for degrees, sometimes it's going to ask you for the length. So we've already done degrees. If I ask you to measure the degrees and to tell me the measure of XY, what would you say? Okay. So just like we talked about before, whatever the measure of the angle is, the arc is the same measure. So if my measure of my angle is 45 degrees, then the measure of the arc is also 45 degrees. Now, if it asks me for the length of the arc, you need to be thinking I should have a measurement here that's not dealing with degrees. It's talking about pi. It's talking about inches if you want to even think about it like that. But basically, that's where this formula that you see up here comes from. If I want to find the length of a segment, I will say the degrees over 360. Basically, that tells me what portion or what part of the circle I'm dealing with times the circumference. So for this, it's often going to give you the radius. So you're going to need to use the formula 2 pi r. So you'll say degrees over 360 times 2 times pi times the radius. And if you did all of this, your answer would end up being 3 pi, which mm, just a little over 9. So it's like I think it's like 9.4 maybe. You'd have to do the calculations to figure that out, but somewhere around there. Okay. Do you see the difference? If it's only asking me for degrees, I use the measure of my angle. If it's asking me for the length, I use degrees over 360 times the circumference. Basically, you're finding out what part of the circumference is in that arc. Does that make sense to you? Okay. Okay. So let's look at another type. So now we're going to get our first look. We've talked about our central angles. Now we're going to get a first look at doing things with our chords. So if two chords are the same length or are congruent, then the arcs that form them are also the same, also congruent. And it's true both ways. If I know the chords are congruent, I know the arcs are congruent. Or if I know the arcs are congruent, then that tells me the chords are congruent. Either way, it's true. So if I tell you one, you know the other. If I tell you the other, you know the first one is true. Okay. So if I tell you arcs, you know angles. If I tell you angles, then you know the arcs are also congruent. Another idea here with chords, if I have a chord that is, I'm sorry, if I have a diameter and it is perpendicular to a chord, then I know that it cuts that chord in half. I know that it bisects that chord. So in my problem, it says if BA, which is a diameter, is perpendicular to TV, which is a chord, then I know two things are true. I know that both parts of the chord are congruent to each other. So I would say I know that TU is congruent to VU. And then because those chords are congruent, then the arcs that they form are also congruent. So then I know arc TA is congruent to arc VA. Take a minute, let that process, see if all that makes sense. Questions anywhere. Okay, good. Okay. So this one is actually one of the types that turns out to be most confusing to you. So I actually helped you out by saying, okay, pretend that pink line isn't there for just a moment. If they simply give me a radius and a chord, and they tell me the radius is perpendicular to the chord, first, that tells me because it's perpendicular that this is congruent to this. What it does not tell me is anything about this segment. A lot of us will make the mistake to start saying, oh, that means BX and OX are the same length. We don't know that. Okay. Then it tells me that arc CD is 134, and it asks me to find measures of the arc. That part's easy. What will I know about CB in relationship to CD? Right. CB is half as big. That's right. So if CD is 134, then CB would be 67 degrees. But when it asks me to do something with OX, that is different. That is not something that I can do yet. However, if I will draw this segment right here, okay, what do you notice about the segment from O to C? What do you notice about O to C? Very good. OC is also a radius. So if I read in the problem, it says it has a radius of 13 inches. So a lot of us get focused on O to B is 13 inches. And so you'll say, oh, then that means O to X is half of that is 6.5. That's not true. But if O to B is 13 inches, then O to C is also 13 inches. This is 13. And it tells me that CD is 24. So what else do I know? Okay, so if the whole segment is 24, we already said since it's perpendicular, it cuts it in half. So CX is 12. So how would I find OX over here? Well, that was our whole last unit. If I know two sides of a right triangle and I'm trying to find the third side, that's going to become automatic for you. That's Pythagorean theorem. So you would say your question mark, I just use question mark. You can use a letter if you want. Question mark squared plus the other side, 12 squared, equals the hypotenuse, which is 13 squared. This is a very, 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 very common problem, common type of problem, and lots of you will miss it, even though one of these is on your notes and we cover it in class. You either aren't fully processing what's happening or you aren't paying attention when you come to it. Okay. Questions? All right. So this is another example. I'm not going to go through the chords example because I really want to work on a few other things. First, reminding you about finding the area of a circle. For circumference, we had two different formulas, one for radius and one for a diameter. For area, there's only one formula, which means you must use the radius. And your formula just says that area is pi times the radius squared. Hopefully that's not new to you. Hopefully you've seen that before, but just in case you haven't, it's there for you to remind you about it for most of you. Okay. Just like we did with circumference, where we could take the entire circumference and break it up to talk about just one arc length, we can do the same thing with the area. We can take the entire area and we can multiply it by what part of the area we have. So you'll notice the formula that I'm using here is just like the one we used earlier, except instead of using the circumference, I'm using the area. So it's degrees over 360 times the area instead of degrees over 360 times the circumference. But we'll use that if we want to know the area of just part of the circle instead of the area of the entire thing. Okay. Also, sometimes it'll say leave your answer with a pi or leave your answer as an exact answer. Sometimes it will say leave your answer as a decimal rounded to however many places. Doesn't change the process for what you do. It only changes the final answer. Okay. So, for example, the one at the top with the blue shading, top right, if it's a right angle, we know that's 90 degrees. So 90 over 360 times pi r squared, and then do all the calculations. Does this make sense so far? Good. Okay, so then as we finish here, here is our first look at a different type of angle. The one we looked at first was a central angle, which meant its vertex was in the center of the circle. The one that you see here is an inscribed angle. So for an inscribed angle, the vertex is actually on the circle and it's formed the sides of the angle by two chords. The most important thing here, I'm not going to have an angle and an arc that are the same measure. For this, my angle is half of the arc. So it's half as big as the arc. So if I'm looking at the picture here, if I wanted to find the measure of this angle, I would have to take this arc out here and divide it by 2 or multiply it by 1/2. So here's my crazy example. It says the measure of AB is 140 degrees. This is not drawn to scale, just so you know. BC is 100. AD is the same as DC. Okay, so if I look at those, how will I find AD and DC? Okay, so the way that I could find that, I know the whole thing has to be 360. I know those two parts add up to 100 plus 140, so 240. So if I say 360 minus 240, I would have 120. And since each of these are equal to each other, even though they don't look like it, I would say 120 divided by 2, which is going to give me 60 for each of these. Okay, so here's how it works for inscribed angles. Look at angle 1. I'm going to draw on the picture because I think it's helpful, especially for our first time. I'm going to draw the sides of angle 1. Some of you may find you need to do this on your homework. So that's why I'm trying to end with this. If I draw the sides of this angle, what arc do they enclose? What's the name of that arc? Everybody's gotten kind of quiet. I got one or two of you answered, but most of you aren't saying anything. If I look at the two sides that I've drawn, what arc do they enclose? Okay. So they enclose arc AD. How big is arc AD? Good. So if that is 60, then angle 1 is half of that. So angle 1 would be 30. Makes sense how we got that? Okay, good. Okay, so if I look at angle, these out of the way. If I look at angle 2, some of us, if we need to draw the sides, do it. What arc is enclosed by the sides of angle 2? Good. So if I close it in, the part that's enclosed there is going to be arc CD. CD is 30, which means that angle 2 is I'm sorry, CD is 60, which means that angle 2 is also 30 degrees. Good. So for angle 3, how much is that one? How big is angle 3? Good. So if I follow angle 3 out, it intersects arc BC. So angle 3 is 50 degrees. I agree. What about if I found the measure of angle 4? Good. Okay. And then finally, how about angle 5? Okay. So if you follow angle 5 out, do you see how it also intersects arc BC? So if two inscribed angles intersect the same arc, those angles are going to be congruent. So here is an example of one where you see that. So if you look at this angle right here, QRT, do you see how its intercepted arc for that angle is QT? And then if I look at QST, do you see how its intercepted arc is also QT? So that would tell me that those two angles would be congruent. All right, so we're not going to have time to get to tangent lines, but I did include some notes on that for you. Okay, so anytime you have a tangent line, tangent circles touch the circle. I'm sorry, tangent lines touch the circle. And they touch it at just a single point. And the place where the line touches the radius, the place where those intersect, this creates a perpendicular relationship. So that creates a right angle. All right, so for this week, you have 2 book lessons and 2 lessons on your worksheets, and then you're working on your study guides. Reminder one more time, this week, you have your work, you turn it in on Sunday like normal. Next week is our winter break, so we will not have class, and we will not have assignments to complete. So, thank you guys for being here. Have a fantastic week. Enjoy your break. Get well. And I will see you guys back in 2 weeks. Thanks for being here, everybody. See you next time.